Connecting entities. Pipes and pipelines. The single MEP entities arranged on the drawing, both on the levels and in 3D, can be connected to each other to create complete system networks and for which you can define multiple aspects. When you activate entities such as pressurized pipes, other pipe types, air ducting, cable trays and pipes for electrical distribution etc., the Characteristics section appears in the Properties toolbox. This allows you to assign the material, the profile, size, push-fit fittings, and other piping-like settings. The first field shows the Smart MEP, which by default is activated and allows you to automatically generate the fittings set in the subsection fittings, and which include the curve, the T-fitting and the transition. The operating modes of the Smart MEP will be explained in the following dedicated lessons. Each of the MEP entities are associated by default with a dimension and a profile from those present in the library of the general library, whose properties are shown in the fields in the Features section of the toolbox. Once the entity is activated from the drawing menu, the associated piping tab by default is copied to the project library. As an example, suppose you enable the entity pressurized pipes for insertion. The material type is shown in the piping field, which by default for this element is copper. By clicking on the piping field, 3 buttons appear. The plus button allows you to configure a new custom dimension with respect to the geometrical parameters automatically associated with the selected pipe, which will be added to the profile sheet chosen, in this case copper. The central button allows you to open the Bim Objects Library editor. It allows to make changes to the profile sheet of the activated pipe, and to Bim objects in general. The third button, with the 3 dots, allows you to access the Bim Object Libraries from which you can choose a material other than the one presented by default. You can choose a material present in the general library relating to the selected pipe type. You can also change the library using the menu at the top. Here you can select the project library or continue to model from the user library. The size field shows the size of the profile as defined in the same column on the piping sheet in the library. In the case of copper for water pipes, the size field shows by default the external diameter, 22 mm, and the thickness, 1 mm. By clicking on the size field, a button with 3 dots appears which allows you to open the card of the chosen pipe and possibly select a different dimension from those in the library. In the annotation field, exclusive to MEP entities, you can edit information to be attributed to the activated entity. The subsection fittings shows the fittings that can be generated automatically starting from the entity activated with the Smart MEP mode. In the case of pipes, the fittings that can be generated automatically are the curve, the T-fitting and the transition. In the subsection connectors you set the type of connections of the ends, A and B, of the pipeline. For the entity in the example, the default associated type is male for both connections, but can be changed by clicking on the field corresponding to each connection. Therefore access the drop-down menu, where it is also possible to choose between female, flange and smooth. For different types of entities, the same argument applies to that seen for the pressurized pipes object, although some fields of the toolbox can refer to different parameters, specific to the specific entity selected. In particular, remaining in the mechanical systems category, if the ducting is activated from the design menu, the pipe field relating to the pressurized and drainage pipes is replaced, with the same functionality, by the duct field. In this field, in addition to the material, the shape of the profile is also shown, as you can model both circular and rectangular profiles for the air ducts. For entities belonging to the electrical installations category, by specifically selecting the electrical piping object, the corresponding field is called model and specifies the material of which the element is made. An additional field called type is shown for the cable tray and cable duct entities, for which the possibility of managing how the cover is shown and possibly inverting its orientation on the drawing is also present. Drawing the connections in 3D. By activating the MEP entity, in the upper toolbar of the 3D modeling window, you can enable the menu to choose the level to which the pipe belongs if necessary. If you leave the value to automatic, the inserted object will be automatically positioned. It can be either associated with the belonging level, identified by its insertion point, or at the same level as the MEP object to which it will eventually be connected. From the menu you can choose one of the levels present on the project, previously defined in the architectural environment, to be assigned to the connection that is about to be drawn, regardless of its height. The tracing of a tube-type entity in 3D is analyzed in detail. With a first click of the mouse, the starting point of the pipe is identified in 3D, which will correspond to the center of gravity of the attachment. Once the starting point of the pipe has been defined, it is necessary to define its plane of belonging. After the first click, in fact, the directional cube appears on the screen, which can be used to trace the pipe along one of the planes parallel to the faces of the cube and passing through the point. Once the starting point of the pipe has been defined, it is necessary to define its plane of belonging. After the first click, in fact, the directional cube appears on the screen, which can be used to trace the pipe along one of the planes parallel to the faces of the cube. A purple line also appears identifying the vertical direction together with the direction cube, and a protractor used to define direction and verse, as specified when choosing the angle. Considering the pipe's starting point in 3D space, we can the cube's X, Y, Z global reference system and notice that the horizontal plane goniometer, in Y and Z, is active. In this condition, you can only trace the pipeline along the horizontal plane. To choose another plane of the cube, just move the mouse over the corresponding face of the cube and click on the blue part of the face. The choice of the plane also involves moving the protractor on the selected plane, and the V-axis, the vertical planes, and horizontal H-axis will be present. If you do not want to constrain the pipe to remain on one of the floors identified by the cube, you can ignore its use by clicking on the padlock that appears next to the protractor. Unlocking the padlock makes the directional cube disappear. In this way the pipe is released and is free to be traced in 3D space. In that case, a second click will be enough to directly define the end point of the pipe. To reconstrain the pipe to lie on one of the planes of the cube, it is necessary to click on the padlock, so as to make the directional cube and the protractor appear in the default position. If the directional cube is used, once the plane has been chosen, a direction and a direction must be assigned in a subsequent step. The protractor can be used for this purpose. By remaining with the mouse inside corner will snaps appear, allowing you to assign the direction and verse corresponding pipe. The main angle snaps are represented by the X and Y axes, which identify the directions of the axes of the global reference system. They correspond to the angles 90 degrees and -90 degrees along the X-axis, and 0 degrees and 180 degrees along the Y-axis. From the starting point of the pipe, by moving the mouse towards the circumference of the goniometer, the secondary angle snaps identified by multiple angles of 45 degrees are intercepted. Then continuing with multiples of 15 degrees, and near the circumference also multiples of 5 degrees. Once the angle has been identified, a click of the mouse is enough to fix the pipe along the direction and according to the chosen verse. A ruler appears on the screen that can be used to define the pipe length in the next step. If you realize that the chosen angle is wrong for some reason, go back to the previous step by clicking on the cube on the starting point of the ruler. In this way you can choose another direction or another plane. If the direction and verse of the pipe require an angle that is not defined in the angle snaps, just move the mouse outside of the protractor area and fix the direction and verse manually with a click of the mouse based on the angle value read along the circumference of the protractor. The value is accurate to the 100th of a degree. The angle can also be typed in from the keyboard, or defined with a click in another point of the identified plane. Once you have chosen the direction, to define the length you can use the ruler that appears on the screen in the next step. When you zoom in on the pipe, snaps appear on the ruler, allowing you to define the length in multiples of 5 centimeters. If you zoom away from the pipe, snaps thicken along the ruler with multiples of 10 centimeters, 50 centimeters and 1 on a large scale. If the length of the pipe cannot be defined with the multiples present on the ruler, just move the cursor outside the ruler and set the length with a click of the mouse based on the value read along the edge of the ruler, with a precision that depends on the decimals are set in the program's unit of measure settings. Alternatively, this value can also be typed in from the keyboard or defined with a click in another point along the chosen direction and verse. Using the directional cube, or freeing from its constraints, it is also possible to define the connection position, and therefore obtain the pipeline in 3D, with the system and the set characteristics. By selecting the inserted pipe, labels A and B are displayed, which specify the position of the centers of gravity of the corresponding connections, whose connectors are precisely those set in the Features section of the toolbox, in this case both of the male type. Another potential, inherent in the use of the direction cube, is the possibility to trace the pipeline in 3D in section views with respect to the selected plane. If you get nearer to the cube's face, it will be highlighted in blue and a circle appears in its center, which will then turn black when highlighted with the mouse cursor. By clicking on that circle, the program automatically arranges the view on the chosen plane. You are always in the 3D view and you can trace the pipe according to the same steps seen previously, with the only difference that the view is that of a section plane parallel to the face of the cube activated and passing through the center of gravity of the attachment of the piping. Since this is a section plane, all objects present between the plane and our view will be excluded from the view. The section plane passes through the center of gravity of the pipe attachment, so the pipe will also be cut in this view. In the section view, it is not possible to disengage from the cube or choose another plane. It is necessary to orbit with the right mouse button to display the cube and its padlock again and, if necessary, continue tracing the pipeline in the selected plane. Drawing connections in plan view. In addition to the possibility of using the pipe modeler in the 3D view, it is also possible to trace the connections in the plan on one of the foreseen levels. The steps that allow you to model the pipe are essentially the same as in 3D view, with the only variations due to the two-dimensional environment, which can be summarized as follows. In plan view, the level assignment is not supported using the same menu that instead appears in 3D. As the pipe will belong to the level on which it is being modeled, and once completed, it can be assigned to another level when necessary. Since you are working on one level, you can model the pipe only on horizontal planes. Therefore, since the plane is already fixed, the directional cube does not appear to choose other planes but only the protractor. It is not possible to work with a section view of the plan but only with the view of the level. After having activated a connection entity from the drawing environment, the system, the profile, the size and the type of the connections are assigned, and then the modeling on the level is carried out, defining the starting point of the pipe with a first click of the mouse, which will correspond to the center of gravity of the connection. In the next step, you need to set the direction and the verse. After the first click, the protractor appears on the screen, which, as in 3D, also in 2D can be used as a tool to define the direction and verse of a pipe by means of the angle snaps that appear in reference to the protractor itself. The main angle snaps are represented by the X and Y axes, which identify the directions of the global reference system axes. They correspond to the angles 90 degrees and -90 degrees along the X-axis and 0 degrees and 180 degrees along the Y-axis. From the starting point of the pipe, by moving the mouse towards the circumference of the goniometer, the secondary angle snaps, identified by multiple angles of 45 degrees, are intercepted first, followed by multiples of 15 degrees and multiples of 5 degrees near the circumference. Once the angle has been identified, with a click of the mouse the pipe is fixed along the chosen direction and verse. A ruler appears on the screen that can be used to define the pipe length in the next step. If you realize that the chosen angle does not identify the direction you are looking for, you can go back to the previous step by clicking on the square on the starting point of the ruler. In this way you have the possibility to choose different directions. If the direction of the pipe require an angle that is not defined in the angle snaps, just move the mouse outside the protractor and fix the direction with a click of the mouse based on the angle read along the circumference of the protractor, with an accuracy to the 100th of a degree. The angle can also be typed from the keyboard, or defined with a click in another point of the plane identified. Once you have chosen the direction, to define the length you can use the ruler that appears on the screen in the next step. When you zoom in on the pipe, snaps appear on the ruler, allowing you to define the length in multiples of 5 centimeters. If you zoom away from the pipe, snaps thicken along the ruler with multiples of 10 cm, 50 cm and 1 m on a large scale. If the length of the pipe cannot be defined with the multiples present on the ruler, just move the cursor outside the ruler and set the length with a click of the mouse based on the value read along the edge of the ruler, with a precision that depends on the decimals, set in the program's unit of measure settings. Alternatively, this value can also be typed in from the keyboard or defined with a click in another point, along the chosen direction and verse. By following these steps, you can model the connection in plan, associating it with the system and the desired characteristics. By selecting the inserted pipe, labels A and B are displayed which specify the position of the centers of gravity of the corresponding connections, whose connectors are precisely those set in the Features section of the toolbox, in this case both of the male type. Editing the model. After tracing a pipe, you can select it to graphically modify the geometry and position of the created model. When you select a pipe in 3D, it turns red and its axis is represented with a dashed gray line. The length of the pipe and an anchor are shown in the center, accompanied by a triad of axes, whose actual position is identified by an orange circle, by default located in the center of gravity of the pipe. A gray arrow in the direction of the pipe axis, a green arrow in the direction orthogonal to the pipe axis, and a pink circle in the center correspond to the centers of gravity of connectors A and B. Using these object grips you can graphically modify the model in 3D. The anchor allows you to move the pipe rigidly in 3D space. By clicking on the orange circle that identifies the node on which the anchor is positioned, the pipe snaps to the mouse cursor and can be moved in 3D. At the same time, a ruler icon and a blue arrow appear on the screen, with the origin point fixed at the previous position of the orange circle, while the other end follows the displacement of the pipe, whose distance from the initial position is dynamically reported in association with the arrow. By clicking on the icon with the ruler symbol or by pressing the A key from the keyboard, the measurement is activated. With a second click, a rigid segment will be represented between the initial attachment point of the anchor on the pipe and the point chosen in space, with relative numerical distance. However, the pipe will still be hooked to the mouse cursor to be repositioned, taking the chosen point as a new fixed reference. The same operation can be repeated several times to identify, for example, the distance with respect to several reference points, until the pipe is definitively fixed in the desired position. If you want to change the position of the anchor, which by default is in the center of gravity of the pipe, you can use the F5 or F6 keys from the keyboard after selecting the pipe, or simply click directly on the anchor icon that it will be moved to the next node. By clicking on the icon representing the triad of axes, shown next to the anchor, the object grip for rigid rotations and displacements of the pipe is activated. By default, the object grip is centered in the orange circle corresponding to the anchor positioning point and is arranged in the plane perpendicular to the pipe axis. By selecting the orange circle or the blue ring that surrounds it, the pipe will still be hooked to the mouse to be moved at a chosen distance with respect to the initial positioning point. In particular, starting from the selection of the ring, this remains visible during the movement, indicating the plane perpendicular to the axis of the pipe on which the movement itself is constrained. Then, observing the object grip from its center outwards, both vertically and horizontally, in both directions, the following symbols are observed in order: an orange arrow for rigid displacement in the direction of and towards it identified, an orange circle to enable the rotation of the pipe around its axis by an angle chosen by moving the mouse or by typing the value from the keyboard, a solid arc of green color that allows you to rotate the orientation of the axis in the plane. The latter can in turn be redefined by clicking on one of the faces of the gray cube that appears in association with the object grip. This identifies the plane parallel to the face chosen on the cube and perpendicular to the axis of the pipe. Consequently, all the elements of the object grip will be repositioned in the new chosen plane. For the cable tray and gangway type connections only, in the case of electrical systems, and ducts with rectangular profile, for mechanical systems, you can set a rotation value around its axis also by inserting the angle value in the rotation field that appears in the geometry section of the properties toolbox for these objects. The gray arrow corresponding to the connections allows you to change the length of the pipe, if you click with the mouse on the arrow, the pointer, which takes the form of a double horizontal arrow, is positioned in the center of gravity of the corresponding connection, while the opposite connection remains fixed in its position and the pipe changes its length according to the movement of the mouse. At the same time, the ruler appears that can be used to define the new length, which can alternatively be typed from the keyboard. In addition to using the gray arrow, the length of the pipe can also be changed by clicking on the length value that appears in the center of the pipe and entering the new value from the keyboard. In this case, it is necessary to provide the software not only with the value of the length but also the node to be kept stationary. This setting is defined in the first field of the geometry section, called fixed point, in the Object Properties toolbox. Alternatively, it is also possible to modify the length by modifying the value that appears in the length field of the Properties toolbox, and also in this case it is necessary to define the second variable represented by the fixed point. The selection of the fixed point can be made by clicking on the drop-down menu of this field and choosing between the options A or B. The green arrow, on the other hand, allows you to change the height of the selected attachment, leaving that of the opposite attachment fixed. If you click on the green arrow with the mouse, the pointer takes the form of a double vertical arrow and is positioned in the center of gravity of the corresponding attachment. The displacement of the selected attachment is constrained along its vertical, and you can reshape the pipe by setting a new value for the height referred to the zero of the building. Furthermore, for this property you can choose the elevation value on screen or type it from the keyboard. As a result, the pipeline length is automatically adapted and changed. The pink circle allows you to reshape the pipe, leaving the opposite end to the selected one as a fixed point. When you click on this circle, the directional cube is reactivated and the initial condition of the tube being inserted is restored. From here you can trace the pipeline in a different direction and/or plane. Once the piping has been modeled, the information related to the model is shown in the Properties toolbox in the Geometry field. In addition to the fixed point and the length, there are also other fields whose values are shown in gray as they cannot be modified because they are set by default based on the chosen model. Depending on the type of entity being modeled, these fields are variable and can be their external surface, obtained starting from the length and the external profile of the pipe. The mass, obtained from the length and mass defined per linear meter in the pipeline library. The slope, obtained on the basis of the inclination of the pipe with respect to the horizontal plane. The profile characterized by the type of attachment, circular or rectangular, by the external diameter, from the internal diameter and by the thickness, all characteristics that belong to the profile selected in the library. In the Properties toolbox there is also the Insulation and Coating section from where you can assign insulation or lining to the activated piping. By clicking on the Insulation field, 3 buttons are enabled. With the third button you access the libraries, from which you can choose an insulating material among those present in the general library, or possibly customized materials in the project or user library. Finally, in the Insulation Thickness field you set the thickness. Once the insulation has been assigned, a coating can also be assigned by proceeding in the same way. Insulation and lining are properties that remain associated with the pipe, regardless of the profile and type of pipe chosen. To remove the insulation and the coating, select the Insulation field, click on the first button represented by a rubber and confirm the removal of the element. If you want to remove only the coating, carry out the same steps but only on the coating field. Besides the geometry, all the other properties of the selected pipe are shown in the toolbox on the right. You can assign it to another plant or to modify its characteristics. In the Altimetric Reference System section, the level to which the pipe belongs are shown in the level field and the height, with respect to the level, of the node where the anchor is positioned in the delta field. By moving the anchor to one of the pipe's other nodes, you can also read its height value. By modifying the delta field, the pipe will be rigidly translated along the vertical and the value set for the height will be assigned to the node on which the anchor is positioned. The level to which the pipe belongs, on the other hand, is a property of the pipe, therefore each node belongs to the same level. You can assign a different level to the pipe, choosing it from those available in the corresponding drop-down menu, and automatically the delta field will be updated to the value of the quota referred to the new level of belonging. While in 3D the pipe remains fixed in its position, in the two-dimensional view it will be visible only on the level assigned to it. Also, on the levels you can modify a pipe in the same way as in 3D but with the following limitations due to the representation in 2D. There is no green arrow to move a node vertically. If the pink circle is activated, the protractor appears to reshape the pipe. In correspondence with the object grip, the cube for identifying a different floor is not available while all the other functions valid in 3D are active. Furthermore, 4 circles appear, each with a different symbol, for enabling, in order, following functions: the padlock to move the positioning of the object grip to one of the sensitive points proposed on the pipe, the icon of the object grip itself, active by default, the object grip for mirroring the element according to the specified axis, the object grip to iron the item. All other 3D view editing operations are also valid on the layer. The flexible and the corrugated. From the drawing menu you can activate the flexible entity for the 3 categories of pipes: pressurized, exhaust, air, of the mechanical systems group, and the corrugated entity for the electrical systems group. From the properties toolbox you can carry out all the operations already seen for pipes and ducts, such as assigning the system, choosing the material from the library, defining the size and so on. Once the material and the size have been chosen, it is necessary to define the point of origin of the hose as well as of the electrical corrugated pipe. Whether this point is chosen freely in 3D space or if you choose the attachment of an MEP entity already present on the drawing, at the first click of the mouse for insertion, the preview, in transparency, of the flexible connection appears. Once to draw, accompanied by a protractor that allows you to graphically define the angle in the XY plane with respect to the x-axis. Along the axis of the flexible, the length of the section being modeled is shown dynamically and a gray circle appears in correspondence with the cursor, which will define the second point of the flexible. The second point of the hose can be defined graphically with a click, for example at the attachment of an MEP object, or you can choose the angle of inclination with respect to the x-axis and define the length graphically or by typing it from the keyboard. Once the first section has been defined, you can finish drawing the hose by clicking on the button represented by a green flag in the top bar of the drawing menu or right-clicking and choosing the finish item. Alternatively, you can trace successive sections of the hose, possibly using the protractor, which reappears as the initial entry, and typing the length of each section from the keyboard, or positioning the endpoint of the section graphically in 3D. A broken line is therefore associated with the path of the hose that joins the segments of the various sections that are defined in the modeling. It is important to underline that the length that defines the section being drawn is that of the segment that joins the 2 ends of the section and not the actual length of that portion of the hose, which instead also includes the curvature. Furthermore, the sections that are drawn from time to time allow you to define only the path of the flexible, therefore there will be no joints at the nodes. At the end of the drawing of the flexible it is possible both to read its properties in the toolbox and to make changes on the path. If you select the hose with the left mouse button, it is highlighted in red in transparency and the labels A and B relating to the connectors appear at its ends. Furthermore, by clicking on one of the connections, a broken line appears that joins the ends of the sections that make up the hose, if there are more than one, otherwise it leads back to a single line. The segment relating to the selected segment is highlighted in green and all the others, if present, in red. Relative to the selected section, the extremes are specified with the numbers 1 and 2, and highlighted with gray circles. The length of the selected segment is also shown in gray. In the toolbox on the right, in addition to the usual properties already seen previously, the value of the overall length of the flexible path is shown in the length field in the geometry section. The properties external surface and mass also refer to the same. Below, the geometric details of the selected hose section are shown, in particular, the length of the segment that joins the ends of the selected section, the angle it forms with the x-axis, the coordinates of the node 1, with respect to the 0 of the building, the type of curvature that can possibly be attributed to the node, and the relative ratio RD curvature. Following are the coordinates and the bending relative to the node 2. To change the coordinates of one of the nodes of the selected section, just click on the corresponding node field, then on the button with the 3 dots that appears on the side. In the dialog that appears, you can change the coordinates, X, Y, Z, and automatically the hose will be reshaped according to the new position set. It is also possible to graphically modify the position of the nodes by clicking with the mouse on the gray circle that appears in correspondence with the nodes of a selected section and then defining the position in space, possibly using known points on the drawing. If the flexible or electrical corrugated pipe is made up of more than one section, you can define the curvature type in correspondence with the internal nodes. If one of the sections of the flexible is selected, the selected section subsection of the toolbox contains the type curvature for each of the 2 nodes of the section that allows you to choose between the options with bending or with spline, defining the type of transition assigned to that flexible connection section. Following the setting of this property, the radius-diameter ratio field becomes editable and you can assign a different value to the one proposed by default, which can be chosen either from those in the menu or typed from the keyboard in the factor field. Furthermore, if you select one of the sections that make up the flexible and click with the right mouse button, you can intervene on the nodes using one of the proposed functions to make the changes described below. Add node allows you to add a new node starting from the last section created on the flexible. Insert node allows you to add a new node in the midpoint of the selected section. Delete node allows you to delete the node of the selected section. Delete previous nodes allows you to delete all the nodes that precede the selected section, if any. Delete successive nodes allows you to delete all the nodes that follow the selected section. Delete object instead allows you to delete the flexible from the drawing. The same operations can also be carried out using the Edit button in the top bar of the drawing menu, where the option of applying an offset to the selected hose is also available, both positively and negatively. It is also possible to delete a single section selected using the delete key from the keyboard, and the flexible will be automatically reshaped based on the remaining nodes. It is also possible to model the flexible on levels in the same way as for 3D, with the usual limitations of a 2D view.